So, all right. So we've gotten the flat water, we've gotten the close sun with the clouds. One idea that I've brought that's new that nobody has brought up is shooting stars. There is a theory that the stars happen cyclical. So when you see a shooting star flash across the sky, you can come back at the exact same time later and see that star. But anyway, alright, so I wanted to focus on the Western Star. So if you're in America, it would be when the sun goes down and it gets dark, you would look at the west. Oh, that's the moon. Okay. You can't really see it in this, but if you look at those two lights, the one on the right is the Western Star, and the other light is the moon. It's a crescent moon right now. Okay, yesterday, so that star is always at the same spot every night, but the moon isn't, of course. Now, if you'll look, yesterday, the moon was to the right of that light. So in 24 hours, the moon has moved a vast distance across the sky. And we have these distances. Now I want you to think about what's going on here. If we were on a spinning ball, what they're giving us is they're saying that the Earth is spinning and then the moon, every 24 hours, the moon is at the same spot at night. Almost. So, it retrogrades every night a few inches according to your field of view. So, okay, so it retrograded, a distance over the night. But here's the thing. Go take a globe and spin it 24 hours. What's going on with the moon? What is the moon doing? Is the moon traveling with the spin of the Earth or against it? Well, it's spinning with. But here's the thing. When NASA showed the only film of the moon transiting the Earth, go look at that video. They had the moon traveling faster than the speed of they had the moon in that animation. Well, I call it an animation, but supposedly it was a real shot. They had the moon, holy cow, that scared me. They had the moon spinning or transiting the Earth faster than the spin of the Earth. I want you to think about that. They showed the moon if I was to say the Earth spins, so if you're looking at the screen of the Earth is spinning from the left side of the screen to the right. So they had the moon going from the left side of the screen to the right faster than the Earth spins. But what does your experience tell you? Your experience tells you, go look at the moon right now in August or the end of July, 24 hours from now. So supposedly we are spinning and the moon is spinning with us. It's going the same direction. It's really weird, you guys. It's really weird what they're doing, because they're saying that the moon is orbiting the Earth. But it's impossible. On a flat Earth model, it makes sense. On a flat Earth model, the moon is orbiting the Earth. The moon is orbiting the Earth because it's spinning around the Earth. And it's just going at a different speed than the sun is. So on the globe model, you can see how stupid and how ridiculous it is, and it's a lie. And any lie is ridiculous when you really look at it. But the way, if you yourself test this, if you get a globe and you get a moon and you do what they say the moon does, if you take the time to do it, you'll realize, oh my goodness, like, it is so stupid. It's impossible what they're saying. It's impossible for the moon to be traveling with the Earth. That's what they're saying. They're saying the moon is traveling with the Earth as far as the spin of the Earth. So the Earth is spinning, and the Earth and the moon is spinning too. The moon is going around. But you got to realize, when they showed the animation, they showed the moon going across your TV screen, and it goes across your TV screen, but they have it keep going to the right, as if the moon doesn't circle the globe. And ask yourself some questions. Say, well, what about 24 hours later? Or, where's the moon? What about 3 days later? What about night? What about day? If you just ask yourself these questions, where would the moon be? It is impossible with their model. Their model does not work. And the animation that they gave people, go back to the eclipse. The shadow of the eclipse, there was a shadow on the Earth that went west to east. But the moon doesn't work that way. The moon's shadow would have gone from east to west, because that's the way that the sun travels. Anyway, it's really cool if you go outside and you look. It's really cool if you go look. See, I went and looked. So whatever is the west sun, west star. It's if you're in North America, you know what I mean. You go outside at night, and it's the brightest star in the west, and it goes down to the horizon about midnight. So you can only see it for like 3 or 4 hours or whatever. So by your perspective, if you look up at the moon and that star, and from your perspective, if you measure inches, yesterday the moon was about 1 inch to the right of that star. And I was wondering this. I was wondering, why don't we get time-lapse photography from NASA showing us the moon and that bright star interacting with each other over 24 hours? Because you would actually see a huge change in difference, a huge change in position between any star and the moon. I mean, I can't believe it. I'm looking at it right now. It was about an inch to the right of that star last night. And it's really weird now because from my perspective, from your perspective, it's above that star like 6 inches. And it's to the left about the same. So it's about to the left about 6 inches and then up 6 inches. Kind of interesting, kind of like a triangle, huh? And so in one day, I bet there's some really cool math with that. But anyway, so it went above that star, and then in one day, you guys. But in the NASA model, the moon would be way to the left. Every 24 hours, it would. So using inches, and you know what I mean. Like when you're looking at the moon, using inches across the sky. According to what NASA filmed of the moon, it would change like half the sky. It would change like a foot or 2 feet every 24 hours. I mean, it would actually be crazier than that. But that's their own footage that they shared with us. So it's fake, but on a flat Earth model, the position of the star is, I think, here's a question I have for the flat Earth people. Do stars travel at the same speed as the sun? Because it looks like they do. It looks like they travel at the same exact speed, but maybe a little bit slower. I don't know. Because it seems like the stars are always in the same position every night. So, where is the North Pole, by the way? I don't know. So the moon, now let me show you again with the camera here. And if I see a shooting star, I record it. I record the time and date. And then I'm going to come back a year later. All right, I don't know if you can see it. Okay. So you see the moon, and you can't really see the star now, but it's about 6 inches below it and 6 inches to the left of it. So tomorrow, when I come out, I'm guessing it will be 6 inches further. So, you know, every night, and what I mean is it's like a hand length. So I don't know if the moon moves a hand length every night, a retrograde. I don't know if it retrogrades every night, but that's pretty cool if you think about it. You know, let me measure right now. Yeah. So if I roughly just put my hand down there, it retrogrades. So think about it. They have the Earth spinning, and it's spinning from west to east, which is really weird. So the Earth is moving from west to east. But so is the moon. They have it spinning in a weird way, or traveling around the Earth in a weird way. And they always have one side of the moon facing us. It's all convoluted. It's a big mess what they've done. But anyway.